This is Chlonos. It started off as a toy that I made for my baby son, with a few flashing lights and some sound effects, but it's developed into something a bit more interesting. It's got this LED display, which has 126 LEDs. It's got a speech synthesizer chip, which can generate speech and some other sound effects. It's got a real-time clock, so it tells the time, and it's got a temperature sensor as well as a light sensor. And what that allows me to do is to program it so it can do all of these interesting graphical effects on the display, but it can also tell the time in speech. So essentially it's just a talking clock with a few extra nice to have bits and bobs. So let me open it up and show you what it looks like inside, and then I'll show you what it can do. Now this is the brains of the box, the Arduino Uno, and it's a microcontroller platform that allows you to execute software on this chip to control all of the input and output pins, which will then control the rest of the whole gadget. Now how it works is you develop your software on the PC for this chip, you then load it onto this chip using a USB cable that's included over here. You can then plug out the USB cable, and when you give this power, it'll run the software on this chip and control these input and output pins that you see on the top and the bottom over here. Now it's got a lot of these pins, and they can do many different things. It's got digital input and output. In other words, you can send a 1 and a 0 to each of the pins, and then it writes a 5 volts or a 0 volts to the pin, and that you can then use to output to an LED to make an LED go on or off, or control other chips, or anything like that. Now it's also got analog inputs and outputs. So an analog input could be something like a temperature sensor, which I've used on this project. So it can then read the temperature from another chip, and then process that using the software, and then control some other output so that you can have a display change, for example, if the temperature reaches a certain point. It's really cheap as well. I think I paid £4 for this on eBay, and it's really easy to program. You simply do it in C. One of the reasons the Arduino platform is so popular is it's because it's very open. The hardware itself is open source, and the software, even for the IDE, is open source. So it's got a very strong community behind it. They're all develop and try and improve this platform. And because it's so open, you have a lot of third-party developers who create additional add-ons to the Arduino, and they call that shields. Now you can see the way that this is put together. It's got sockets on the ends here for each one of the pins, and what that allows you to do is to attach what they call a shield to this. Now a shield is just another board which has pins that fit into these sockets, and then you have an additional board on top of that. That can do whatever. You can have a motor controller shield, you can have a Wi-Fi shield, any additional add-on functionality. You just simply plug into the Uno, and then it works, and it's pin compatible. Now that's what I've done for this project. I've built my own shield. Now I don't want to be soldering on the Arduino board itself, so I've created a shield that has all my solder on it. And this is what the shield looks like that I've developed. And it's got all the chips and everything that I need, and it simply slots into the Arduino. Get it wrong way around. Slots into the Arduino like that. And now it's got an electrical connection to the bottom, and all the chips on top then have their signals connected. So if I take that off for a second, take the Arduino off. Now this is the board that I've developed. Now, it's based on a very cheap PC board that I got off eBay. That's essentially just a shield that fits onto the Arduino as it is, and then you can solder everything else onto this. Now, this bit over here is the real-time clock, and this has a crystal, which is this metal cylinder over here, and the crystal resonates at a very specific frequency, and then it's got a little CPU over there that counts every single oscillation of the crystal and works out what the time is based on that. And then that gets connected to the Arduino via the wires you can see going there. It's got a backup battery on the back, so if it loses power you don't have to reset the time all the time, which is quite useful. This in the middle here is the Speak Jet chip, which is the speech synthesizer, and you control this via the Arduino. You send it phonemes, so it all works phonetically, and then you construct sentences and you instruct this to speak those sentences. And then the output of the SpeakJet goes to this chip over here, which is just a basic audio amplifier chip. And this is a very simple circuit that just amplifies the sound coming from the SpeakJet and sends it to this speaker over here. Very straightforward. And then I've got two sensors. The one is the light sensor, which is basically a variable resistor, light sensitive resistor, so it changes resistance as the light level changes. And then I've got this temperature sensor over here, which sends a voltage corresponding to the current temperature to the Arduino. Both these sensors send out analog outputs, and then I use the analog inputs on the Arduino to measure the voltages coming from them, and then the software determines what the light level and the temperature levels are. So that's pretty simple, and that's all the electronics I needed to solder. A lot of cabling, but not much else. Now the last bit of the puzzle is the LED display, which is this. As you can see, this is just an array of 1 centimeter LEDs, and these are all blue LEDs, blue clear LEDs, and this is called the LOL shield. And there's a company that develops this, that creates it for you. You can either buy it in kit, so you get all the LEDs and you have to do the soldering yourself, which will take hours. Or you can buy it like this, which again I got on eBay for, I think it was £10, which has all 126 LEDs connected to it. And then it's got the pins that you connect to the shield, as I mentioned earlier, to the Arduino over here. Now this uses a very interesting concept called Charlie plexing. Normally when you have an LED, you have to drive that LED and light it from one pin on your microcontroller. So you have one pin or one port output going to each LED, so you turn it on and off individually. But that would mean you'd need 126 pins on your microcontroller, which is very impractical. Now to get around that, this LOL shield uses what's called Charlie plexing, which you can read up about. I'm not going to go into a lot of detail, but essentially it uses the tri-state nature of the pins. I.e. that a pin can be either a high or a low or a high impedance output, and then by wiring up all the LEDs very cleverly, you can actually turn off many different LEDs using only a few pins, and that's what they've done here. So I only used this many pins, you can see the connections over there, for all of these LEDs. When you turn it on, it greets you and it tells you the time, as you've heard, and then it cycles through a whole bunch of different modes. So here you can see the ping pong mode, it just shows you on the screen, and over here it shows the time, and then it shows the temperature on top with a record high at the bottom and the record low at the bottom. Some random lights turning on and off, and here you can see a bouncing ball, bounces around a bit more. And this is just a rotating helix, supposed to look like DNA. It just looks pretty. And it carries on like that, cycling through. Every hour on the hour, it announces the time in its voice. And it's got a button that you can press, and the button then turns on or off the sound effects for the bouncing ball and everything else. If you want to find out more about this project, I've created a Google Code project called Chlonos, which you can find in the description below. I've got the list of the components, and you can also download all of the source code from there, and it's got my contact details if you have any questions, so do let me know, and enjoy!